Hey, I'm Yakov, and this is another episode in my mini-series on protocols. Previously, I covered why protocols exist and how they work, and explored a few really powerful features of protocols in Swift, including generics and associated types. But apparently, 4 videos are not enough to cover every important aspect of protocols in Swift. That's why I've been working on a few more episodes. In them, I delve into a few advanced level topics. Maybe you don't use them every day, but if you want to really master protocols in Swift, I think you'll find these videos pretty helpful for that purpose. Today, I present you the 5th part in the series. This time, I'll be using Swift protocols in Objective-C and vice versa. You might consider Objective-C outdated, but if you develop apps for any Apple platform, then the legacy of Objective-C still affects your work every day. So let's have a look at how protocols in Swift and Objective-C are similar, how they differ, and how you can combine them efficiently in your projects. If you find this video helpful, don't forget to give it a thumbs up and subscribe to the channel for even more engineering content. And if you want to help me create that content, you'll find the support links in the description. With that said, let's get started. Objective-C is a language with a pretty long history. It was created back in the 80s, and truth be told, it hasn't changed that much until this day. But the concept of protocols or interfaces, it has an even longer history in software development. So it shouldn't surprise you that Objective-C has a mechanism for the very same purpose. Protocols let you define shared traits and behaviors. When Swift was introduced over 10 years ago, its seamless compatibility with Objective-C was one of the key selling points. When it comes to protocols, Swift more or less delivers on that promise. In Swift, you can use Objective-C protocols without much extra effort. In many cases, they work as is. In fact, you can mix components written in Swift and Objective-C in pretty much any combination. For instance, you can take a protocol declared in Objective-C, implement it in Swift, and then use that implementation as a dependency of another Objective-C component. But you've probably guessed that it's not always that easy. If you've had a chance to work with both Objective-C and Swift, you definitely notice that they have a huge difference in their core paradigms. This difference affects protocols just as well. So while in basic tests, protocols in Swift and Objective-C can interoperate fairly well, you shouldn't ignore their distinctions. I invite you to have a closer look at them. For this video, I built a small demo project, and you can find it at the link below. This is a prototype of a word processing app. It lets you enter some text and say a couple details about it. In the first iteration, this app has a protocol declared in Objective-C, and I want to implement it in Swift. Then another Objective-C component will use this implementation to do its own job. I'll have a couple more tasks later, but for now let's focus on using Objective-C protocols in Swift environments. In a previous episode on protocols, I mentioned that Swift lets you use all sorts of objects to implement them. For instance, when you don't need reference semantics, your protocol can be conformed to by structures and even enumerations. In these cases, you often get better performance and safer concurrency. But in that regard, Swift is sort of an exception. Other programming languages typically reserve value types for primitive things, such as booleans or numbers. Objective-C is one of those languages. When you want to implement a protocol, you have to use classes. And because using Objective-C protocols employs the Objective-C runtime, Swift has no choice but to inherit the same restrictions. Basically, when a protocol comes from Objective-C, you can assume that it has the AnyObject constraint. And you can't change that even if you only use the protocol in Swift. That's the case with my demo project as well. Counting the number of characters in a string could easily be implemented in a structure, or even a static method in an enumeration. But because the protocol comes from Objective-C, I have no choice but to use a class. And oftentimes, Objective-C protocols don't simply force you to implement their methods in classes, but actually they require you to use a particular base class. In a previous episode on protocols, I briefly explained the inheritance paradigm. And this paradigm is deeply ingrained in Objective-C. NSObject is the root class of nearly every object hierarchy, because it provides the interface to Objective-C's runtime system. Many protocols expect the conforming objects to have that interface too, and because of that, you're often required to inherit from NSObject. This could have a performance impact in older versions of Swift. That's because inheriting from NSObject used to enable message dispatch for the entire object. Fortunately, this has been fixed, so now other class members can continue using Swift static or dynamic dispatch. If you got no idea what it means, don't worry. I'm planning a separate episode on method dispatch, and I encourage you to subscribe so you don't miss it. One thing you do need to keep in mind is using the Object-C attribute with Swift code. This attribute makes the code visible to Objective-C, but it also makes the code slower, again because of message dispatch. Unless you really need that, I wouldn't recommend using this attribute. But in my demo project, I do need to expose the string manipulator implementation to Objective-C. That's because it is used as a dependency of word processor, another Objective-C object. Implementing the methods doesn't take much effort. But one thing you might notice is that the protocol has 3 methods, but the compiler requires only 2 in the implementation. My code compiles even without the third one. The number of words method is marked as optional, and optional methods in Objective-C are a pretty interesting topic. Perhaps you remember from this video that Swift lets you provide default implementations in protocol extensions. In practice, you might think of them as optional protocol requirements, because they're kind of optional to implement. But in reality, they're not optional. In Swift, every protocol requirement must have an implementation. If you don't provide one explicitly, then it must be present in a protocol extension. And if the compiler doesn't find any implementation, it simply won't build the code. On the other hand, Objective-C offers support for truly optional methods. When you declare a protocol, its symbols are treated as required by default. But protocol declarations can also have this optional section. Everything below it is optional to implement, and everything above is required. Kind of. That's because Objective-C has a pretty loose understanding of what's required and what's not. I'll get back to it in a second, but first one more thing about the syntax. If you want to declare some required methods after optional, you can use this required marker anywhere in the protocol. Effectively, your declaration can have any number of required and optional blocks. And now let's consider the interesting way Objective-C understands the word required. The string manipulator protocol has 2 required methods and 1 optional. As you've seen a minute ago, Swift will happily build the code with only the required methods present. But with Objective-C objects, even required methods sort of become optional to implement. With default project settings, you'll only get a warning if you forget about some of protocol requirements. Otherwise, the project will compile and launch just fine. That's because in Objective-C, nearly everything happens at runtime, so a missing or incomplete protocol conformance technically doesn't prevent the compiler from building the code. This can be pretty confusing when you're used to working with Swift like I am. But luckily, you can change the rules with a single compiler setting. If you want to have a more familiar behavior in protocols, you can add this warning flag in build settings. Let's assume we've done just that, and now focus on optional methods. In my object, I've implemented the required methods but skipped the optional one. What do you think would happen when another Objective-C component calls it? Well, if you work with the language, you know that it has one answer to pretty much any problem. A runtime exception, in other words, a crash. Calls to optional methods which aren't implemented will compile just fine. But when these lines are executed at runtime, your app will crash. To avoid runtime exceptions, you have to manually check if the method is available at runtime. For that, you use the response-to-selector method. This method plays an important role in the Objective-C runtime, and that's why I had to inherit my class from any subject. Of course, it's hard to call this solution elegant, but at least it's better than a crash. Let's assume that in another update, I replace this implementation with a Swift version. This won't solve every problem completely, because the objects still interact through the original Objective-C protocol. But despite that, Swift can make this code much nicer and safer. Swift treats optional protocol methods as optional closures, and you can use them just like any other optional object. If you want to call such a closure, you have to unwrap it. This can be done explicitly or in line. And that is why there's a question mark before the method's parenthesis. Choosing the approach might seem like a no-brainer, right? Who'd want to use optional binding when a single question mark can fix everything? Well, almost everything. There's one really important distinction that often goes unnoticed. If you use inline unwrapping for a method that's not implemented, no code will be called at all. And sometimes this can get you in trouble. For instance, completion handlers are supposed to be called no matter the result. But when you unwrap optional methods in line, it's very easy to forget about the else branch. Only a few months ago, I found and fixed a bug just like that in the Firebase SDK. You probably know that Firebase has hundreds of contributors and many millions of users. But even in a project that large, the intricacies of Objective-C can be just too much to handle. So now I can be pretty certain that even if the optional method is not implemented, the app will handle this scenario just fine. Earlier in this video, I said that Swift doesn't support truly optional protocol methods. It would be more accurate to say that Swift doesn't support truly optional methods in pure Swift protocols. But when a Swift protocol is exposed to Objective-C, the rules change. Let's talk about that. When you want to make a Swift object visible and usable in Objective-C, you mark it with the Obj-C attribute. But this only works with the data types and features which are supported by both languages. Protocols are sort of a mixed bag in that sense. Obviously, protocols in general exist in both Swift and Objective-C. But in previous videos, I repeatedly told you that protocols in Swift are much more capable than in other languages. That's why some of their features can be used in Objective-C, and you have to keep that in mind when you design the protocol in the first place. Generics are one of those features. Objective-C lacks support for generic types, so protocol requirements with generics can't be accessed from Objective-C. Of course, there are workarounds, such as type erasure, but it's hard to call them convenient. You'll most likely have to redesign the protocol without generics. Associated types are another feature of Swift protocols which you can't use in Objective-C. In the previous episode, I explained how associated types enable one protocol to handle many use case scenarios, without typecasting or type erasure. But this feature relies on Swift's type system, and Objective-C is not compatible with it. The same goes for self-requirements in protocols. Because they are related to associated types in most aspects, they have similar restrictions. In my demo project, I wouldn't need generics or associated types. All I want to do is declare a Swift protocol for word processor's delegate. This protocol should be adopted by the view controller, and this view controller is written in Objective-C. The delegate should handle just a couple types of events. The word processor will be telling it when processing starts and ends, and when there's an error in the processing of the input. In Swift, I would declare this protocol in an extension to word processor. But Objective-C doesn't support type nesting, so instead I'll have to declare it separately. Again, if this were a pure Swift protocol, it would probably have a single method which reports processing state. The state can be described within enumeration. But while Objective-C does support enums, they're much more limited than in Swift. So instead of a single method, I'll need to have 3 separate functions. The distinctions don't end here. Let's say the delegate is mostly interested in errors, so it should have a way to ignore other state changes. Swift protocols support default implementations for that. But unfortunately, you can't export them to Objective-C. In that case, you'll have to implement each and every method explicitly, but that is unless you mark them with the optional keyword. You see, unlike pure Swift protocols, protocols exposed to Objective-C can have truly optional methods, with the same features and restrictions I explained earlier. Of course, now you'll have to unwrap the methods before calling them, but at least this solves the practical problem. At this point, the view controller can conform to the delegate protocol, but only implement the methods for reporting errors. While my demo project doesn't show every possible scenario you can encounter, it highlights the key aspects of using Swift and Objective-C protocols together. As a reminder, you can find the source code on GitHub. And from the starter branch, you can retrace my steps or do everything your way. I'd love to see if you know a better approach to the tests on the list. If you have any suggestions, leave a comment below. In summary, protocols in pretty much any language have the same purpose, but they may offer somewhat different tools and mechanisms. I highlighted a few important aspects of using Objective-C protocols in Swift and Swift protocols in Objective-C. I'd say default implementations are a really important distinction. They play a crucial role in protocol-oriented programming. But since Objective-C doesn't support default implementations, it's not gonna be easy to export a complex protocol-based design from Swift to Objective-C. You'll most likely have to rethink the entire architecture, and that's rarely something you would enjoy. So if you suspect that your Swift code will need to support Objective-C at some point, you better keep these limitations in mind from the very beginning. So this has been another aspect of protocols. If you found this video helpful, don't forget to give it a thumbs up. Initially, I planned only 3 episodes for this mini-series on protocols. But now, after 5 videos, I've still got a few protocol-related topics I want to break down. Subscribe to the channel and stay tuned for even more engineering content. And if you want to help me create it, you'll find the support links in the description. I'll see you in the next video. Until then, make your protocols fly.